What's up, C programmers? Welcome to today's video. In this video, we're going to develop our own string library for C. It should be fun. Before jumping to Visual Studio, if you haven't watched this string library video and the video regarding char pointers and strings, there are links in the description below. So let's name the library engm string. I want to develop a function that takes a pointer to a string and calculates the length of that string and returns the length. The function will return an integer, so I'll start with integer. The function name, I'll name it engm string length. And the function takes a char pointer, str. Okay. I'll copy the declaration of the function, go to the end to implement the function. In the function implementation here, okay, I need to create an integer length. This should start from 0. So while the pointer to this array, if I dereference the pointer, while this is not pointing to the null pointer, which is to the end of the array, I want it to continue looping through the array. So this is basically a good thing in the strings, that we can, at the end of each string, which is a char pointer, which is in character array, the last element will always be this null pointer. So it's good for us that we can loop until we reach this point. Now I can loop through this str pointer, this str string, which is the character array, until I reach to the null termination. Okay. And length plus plus. So each time that I'm going through this array, I wanted to increment length by 1, unless the last element, which is the null pointer. But if you look at here, I said str and I dereferencing it. Str, as we basically talked, the name of an array is the pointer to the first element in that array. If I put a star before it, asterisk before it, it means that I'm dereferencing it. So asterisk str means dereferencing the first memory address of this string, which is the first element in this string. But I don't want to always stay on this first element. I want this pointer to, after the first element, in the next loop, I want it to point to the second element. After the second loop, I want it to point to the third element. So I have to increment the pointer str. So we move the memory module as well. And at the end, this is an integer function. It has to return an integer. And the integer I wanted to return is basically the length, which is the length of the array. Okay, let me create a string here. I'll say name and my name, Reza. And I'll call my function. And then as the input argument, I'll put name, which is the string that I want to send to the function. And this function will return length. And I will store the return of this function into integer name length. So if I put a breaking point at line 12 and start debugging this code, what will happen here, you see that we have a length and we have a name. The name is Reza with uppercase R. And if I step into the function, the first thing that would happen is I will initialize length as 0. The second thing is the value of pointer str will be compared by the null pointer. The first thing is R. So if it's compared to null pointer, it will be true. This condition will be true. The while loop will continue. As you can see, we will be going to the body of the while loop. Length will be incremented. Now length is 1. And the pointer right now is pointing to E, as you can see in the local window here. And if I continue stepping over now, then Z, and then A, and then at the last part, it will point to the null pointer. Now, if I step over, we'll go to line 25, which is expected. And in line 25, I will return the length, which is 4, to the main function. And now, in the main function, this length is 4, is not initials, because basically the yellow arrow means that this line hasn't been executed yet. If I step over this line, now the length in the main function is 4, which means that our function returned 4 to the main function. Now I wanted to create a function that takes a string, copy it, and pastes it to another string. So let me close this one. The next function we wanted to create is a void function. It doesn't going to return anything, but the name is engm string copy. This will take a character pointer. I'll name it des for destination, and a character pointer src for source. So we'll take the source and we'll paste it. We'll copy the source, paste it to the destination. Let me create an empty array here. Let's call it str. I'll use the max length here. And let's leave it empty. And the function doesn't return anything, so it can just go ahead and call the function. And the function takes str, which is the destination, and takes the name, which is the source that we wanted to copy. Now let's actually go and implement the function. engm string copy. It's a void function. And the function takes a char pointer destination and a char pointer source. So in this function, I'm going to create an incrementer, I. Then a for loop. This for loop, its job is to go through this function. I is 0, which is I wanted to initialize the incrementer. And then each time, at each loop, I want to check source I. And I wanted to make sure that we are not pointing to the null pointer, which is the end of the array. Because if we're pointing, I don't want this loop to continue anymore. I want to copy until the null pointer. And that's the check. And of course, at each loop, I wanted to increment my incrementer, which is I, by 1. Now in the body, I wanted to copy. So if I'm at the element 1, which is index 0, I want to copy whatever is in the source to the destination. So the right-hand side, the left-hand side would be destination I, and the right-hand side would be src, I. Okay. So I'm copying the ice element of source to the ice element of destination. Now we'll continue doing this until I reach the null termination point. If I do this, I will end up the destination array of a character array that doesn't have a null pointer. So I have to manually go ahead and add this null pointer to the destination array myself. Okay, so what's happening here is I is 0 on the first loop. In this case, we're copying Reza. So R will be copied, I would be 0. E would be copied, I will continue incrementing until I is 5. When I is 5 and I wanted to check this condition is not true anymore. So we won't continue the for loop. But destination will be REZA. There is no null pointer. I have to add the null pointer so it acts like an actual string in my main function. Let's go ahead and debug the code with the breaking point in this function, the second one that we just created. Okay, if I step into the function, you see our variables. So now I is 0, and I'm starting to copy. You see that in the destination array, R is being copied. And then E, and after the Z, and after that A. Now that I is 4, pointing to the 5th element in the array, I manually align 38, add the null pointer. You see that the string ended on the local window. And if I step out, go to the main function, you would see that str is now reza, is not an empty array anymore. Now let's create a function that takes two strings, the pointer to those strings, and then start comparing those strings together. And if they were identical, it will return 0. And if they weren't identical, it will return -1. So this function, it's also an integer function because it returns if the result of the comparison. I'm going to actually name it in GM a string compare. This will obviously takes to string. I'll name it as string 1 and string 2. So the way I'm going to use this function in my main function is the result has to be stored in an integer. I'll create an integer condition. And then this condition will be equal to, the return value of this function will be assigned to this condition. And the function is compare function. It takes two string name and str and compares them together. Right now in line 16, I basically copied them. I know that they are going to be identical because I just copy name to str, and condition should return 0, which means they are identical. Let's put a breaking point here and I'll go actually develop the function. Let me close this one so we have a cleaner code. So integer engm string. Let me actually copy paste the declaration here. I'm lazy. Okay. So the first thing to compare to a string is basically to compare the size. Awesome. So I'll create int length string 1. That equals to engm. I'm going to call my own length function, and then my length function just takes a pointer to that string and returns the length of it. And I'll do the same thing for the second string. So now I have two integers, which are the lengths. The one thing I would do here is I'm going to check to see if these two lengths are actually identical or not. If they're not identical, we're done. We don't need to continue. We just need to return -1 and done. Okay. You see that I'm putting return here. Return is also a control flow statement, like break and continue. When we break a loop, we would get out of the loop no matter what condition is right or wrong. When we saw break in a loop, for loop or while loop, it will get out of the loop. Return is the same thing, but for function. When we reach to the return, if I reach to the return, the code I have after line 49 will be ignored, and we will jump straight to line 51, which is the closing curly bracket. But if this condition was false, this code wouldn't be executed. So this return function would not be executed. And now I'm going to write the code for that scenario, for the scenario that these two lenses are actually equal to each other. If the lenses are equal, it doesn't mean that the strings are equal. I have to compare the strings as well. What I would do here is create a for loop. This for loop has an iterator I, which starts from 0, and this I goes until the length of the array. And be careful that length is not actually the size of the array. I have to go to the length of the array, because from 0 to the length of the array, I mean, I have to use less than or equal sign instead of less than that we used to use for sizes in the array. Because when we say array size is 5, indexes are from 0 to 4. So length of a string is, for example, length of a string Reza is 4, but the size of that array is 5. So that's why you could either go from put the condition I less than or equal to length, or just less than the size, which is length plus 1. I rather to put just less than, because it's only one operation for the code and it's more optimized. And then increment the iterator. And now I can compare the first string, index I, the element I, to the element I of the second string. But I want this if condition to be true if they're not actually identical. If they weren't identical, again, I'm going to return that -1. And if this is not executed, if this body of if condition didn't execute, it means that we went through all of the elements in the string 1 and 2, and all of them were actually identical. So if this if and else don't get to this return statements, I will return 0, which means they're perfectly identical. Okay, let's actually debug the code. This is getting interesting. Okay, let me step into the function. Okay, now the length, if I step over line 45, I expect the length 1 to be 4. Perfect. And length 2 will be 4. Perfect. And now this if condition is false because these two lengths are actually equal to each other. Perfect. We'll go to the else condition. In the else condition, I'm in the for loop. In the for loop, as you see, I would be 0. And if, let me actually make this window a little bit bigger. Perfect. If I step over now, I was 0, so R is equal to R. Everything is okay. I would be 1. We're not going to the body of the if statement. I is 3, and even when I is 4, and we don't need to go over I5 because it's only 5 elements in this string. We basically didn't need to check the last one. I did it just to make my code future proof, but because we expect the last element in the string to be null terminator, we didn't need to check the last one, but I'm doing it. It doesn't matter if you do it or not, but I want to future proof my library here. If somebody enters an string that doesn't have a null terminator, it will actually be able to compare that one as well. So if I step over, you see that I'm on line 61. None of the return values at line 57 and line 49 was executed because these conditions were always false. Now I'll return 0, and if I go back to the main function, you would see that condition is 0. It means that these two strings were actually identical. But if I change the string here, even slight change, just use lowercase r instead of uppercase R. And let me comment these two functions. I don't need them here. And restart debugging the code. And step to the function. The same thing, the size are identical. We'll go to the for loop then in the else statement. And I is 0. But you see, in that I0, comparing uppercase R to lowercase r, this condition was true. So we are at this return -1 statement. Now my code will return this -1, go to the end curly bracket, and back to the main function. Not the rest of the code wouldn't be executed because return statement is a control flow statement that ends the execution of that function. The next function that I wanted to include in my library is a search function. The search function takes a pointer to a string and a character and search for that character in that string. If it didn't find it, it will return -1. But if it were able to find that character in my string, it will return the index of that character in the string. If there are multiple occurrences of that character in the string that I provided in the function, it will return the index of the first occurrence of that character. So this function will actually be an integer function because it will return which element in that array is the element that we're looking for. And I'll name it, because we are searching for something, I'll name it engm string search. This function will take two arguments, as I said, string and a character so we can look for it. I'm going to name it search character. Perfect. So the example of using this function is let's actually create an integer search that will take care of store the return value of the function, and the function name is the search ngm string search. It takes name and character E. I wanted to see where character E is in my name, and I'll move the breaking point here, and let's go actually implement the function. Let me close this. Perfect. So I have an integer function. It should return an integer and takes an array of char, and takes a char pointer, not an array. Basically, it takes the memory address to the first element of that string, and then actually take a char by value. That one is only 1 byte. It's okay to take it by value, and we wanted to compare it against all the elements in the string to see if we can find or we cannot find any equivalent. So what I would do, as we said, the for loop would be the best option here. Not the best option, the option I would go with it, because we know the actual size of the array. I'll create an incrementer I and initialize it 0, and I will continue this loop until the element that I'm checking is not end of the string, because the moment the element I'm checking is basically the null pointer, the terminator, the string terminator, I don't want to continue the loop anymore. And then increment I, and now body of the for loop. In the body of the for loop, I wanted to see if each individual element is actually equal to the search character that we just input into the function. And if it was, because the function will return the first occurrence of that search character, I will return I, and I would be the element that this, the index that this character is actually sitting. So in Reza, if R is 0, E is 1, I expect this I to be 1 because this is the index 1 that holds this search character E. Okay. And in any case, if this return function wasn't this return statement wasn't executed, it means that we couldn't find the search character into this string, and I will return 0, which means that I'll actually return -1 because 0 might be the first, is the first index in the array. I don't want it to have a misconception, which is, do you mean it's the first one or it doesn't exist? So I'll return -1, which means that I couldn't find this search character in this string. Let's actually go ahead and debug the code. Okay, so search, let's step into the search function. As you can see, we're starting the for loop. We're looking for E in Reza. And you see, I'm doing this with bracket I with the name of the array. You can do that with pointers. It's actually a good practice for you in programming. Try to do whatever I do with pointers using with arrays and vice versa. I think I only did the first function, the lens function, using the pointers. Try to do that one with the bracket I using the index, and try to use the other ones actually using pointers. If you can do that, you are mastering the pointer and you can do whatever you want with pointers. Okay, let's go back to our topic. Step over this function. Now, E was comparing to uppercase R and E is not uppercase R, so the return statement wouldn't be executed because this condition was actually false. But this time, I is 1. When I is 1, I expect stri, which is str1, which is E, equal to search character. So this condition should be true, and that is true. The instruction pointer will go to line 72 and will execute this return value. And by executing this return value, it will return 1 to the main function. But returning 1 to the main function, after this line 72, we'll go to the end of the function, and now the return value of this function in ENGM string return value is actually 1. And if I step over the search variable that I created here, that actually will be 1. It means that E is in the index 1 in the string name. Now is the time to convert this into a library. Now I promised you guys to create a library. So let's go ahead on the Solution Explorer. Under the source file, and right click on Add, New Item, and under New Item, I will type engm string.h and click Add. Okay, let me put it actually side by side so we can see both files at the same time. I'll start my library with pragma once. I'll tell you what is it in a moment, but what I want to do, I wanted to cut and paste all the function that I just created here. So all my functions will be here. I don't need the function declarations anymore. And I'm going to call my library the way I call CString library or stdio.h library. But the difference is I'm going to use double quotation this time. And engm string.h is I'm going to use this. So by double quotation, it means that this library is in my code, is in my folder project, is in this actually in this computer. You don't need, it's not something that belongs to C. You don't need to go look for where C was installed to find that library. You have to just look at this local project library to find this library that I have created. Okay. So now I expect all these functions to work. And let's actually see if they work or not. Okay, so my code compiles without any error, but let's step to this function. And as you can see now, I'm stepping to line 46 of this engm string.h. And now I created a library here. The only reason I put this pragma once into my code is because if you accidentally go ahead and use this include engm string library in your code twice, there wouldn't be any problem. So the reason I put this pragma once here, let me actually remove it and accidentally copy and paste this library 2 times. So I'm calling this library 2 times. If I start debugging this code, I'll get a lot of errors. Actually 4 errors. I have 4 functions, and it said this already has a body. This function already has a body. What does it mean? It means that what are you doing? You already have this function. Why are you recreating this function? It's because I accidentally copied this library twice in my code. What compiler would do, compiler when sees this line will go ahead, copy all the content of this file and paste it here. But because I have 2 of it, compiler would do it 2 times. If it do it 2 times, it will see, for example, engm string length 2 times, and it will error me that why do you have 2 of this function? And if I put the pragma once keyword back, it means that take these functions only once at a time. Even if I had 100 copy of this include engm string here, it will only take 1 implementation of engm string length and the rest of the functions in this library. So if I debug this code, you would see that it debugs without any error. Let's add another function into our library. Now imagine I wanted to read a string from the console. So let me actually get rid of these functions, and I wanted an empty string. We don't need that line anymore. Okay, so I'll put a printf statement to tell the user to enter a string. And I'll scan that string. Sorry, %s. And I'll put it into the address of the array string, which is the name of the array string. And let's see what will happen here. I'll put a breaking point on return and debug the code. Okay, it said enter in a string. I'll enter this as Reza. Now you see in the local window, str is only this. The reason is when I press space, scanf function will stop and only reads until that space. The only way to overcome this is to read the strings character by character. Let me show you how to do that. I wanted to add another function to my library. Let me get out of the debug mode. I'll call it's a void function. I don't want the function to return anything. And I'll call it engm string because that's the name of the library. And then I'll name the function scanf. So this is the scanf from the engm string library. this only takes a char pointer for a string. So in the body of this function, what I would do is I want to create an integer I, initialize it as 0, and I'll tell you what in a moment what I'm going to use with this. I'll create an infinite loop, and in the body of that loop, I'm going to keep scanning characters. And where I'm going to put it is I'm going to put it in the memory address of the indices of this string array. So if I is 0, I'm putting it instead of the element 1. If I is 10, I'm putting instead of the element 11s. So this function will take care of reading it character by character. But this is an infinite loop. I don't want it to read this forever. This has to stop somewhere. And apparently it will stop when the user press enter. When the user press enter, you remember we talked about \n. This is the character \n. So I'm going to read it until I reach the character \n. If stri is actually equal to \n, then I'll break the loop. I'll break the loop because we just user press enter. It means that user has already entered the value. I'm gonna add an I++ here because it's a while loop and we need to increment our incrementer. And the other thing I need to do is I have to put the null pointer at the end. So because I have to terminate the string, I have to make it this char array in a string by adding a null terminator to the end of it. Okay, let's use our function here and see how would it work. engm string scanf. I'll put a breaking point here. F5. Ask me to enter a string. I'll enter this is Reza. So if I step into this function and step over, I would be 0. And you see this str is a block 100 byte of my memory, which is not initialized. And if I step over, it will read the first character. Now I haven't placed it in the memory yet. I have to press enter. So here now the T has been read by the scanf function. And if I continue reading H and then I and then S, and you see that I is also being incremented here. And if I continue, this will, now it's \n. Now this if condition will be true. Then we'll go to break and we'll break the code. And then instead of that \n, I'm going to remove that \n, but at line 69. So the last element is actually \n. I'm going to change that \n to the terminator, to the null terminator. Doing that, now I have a string that has an end in it. In this video, we created our own string library to manipulate a string and make our life easier when working with the strings. Thank you guys for watching. Have a great day, and as always, see you in the next video.